Okay, today what we're looking at is taking our basics of probability and odds, I guess, but we're going to deal with just probability. And we're going to incorporate some of our counting techniques like permutations and combinations into probability. So let's first start looking at our working definition of what probability is, or the theoretical probability. And so the probability of any event A is defined as our number of ways that the event can occur divided by the number of ways that anything can occur depending on what our sample space is. So something like the number of ways that we can flip a heads divided by the number of ways that we could flip anything. So 1 over 2 if we're talking about a two-sided coin. So in terms of looking at theoretical probability, the two big things that we have to determine are what is our event A, the desirable event that we're looking for, and S, so what's the sample space we're looking at. So determine the probability of drawing a heart out of a standard card 52 card deck. So let's define the event A as being draw a heart. Okay, and the sample space is 52 cards. Well, our sample space isn't really 52 cards. Our sample space is, I guess, drawing any card. Okay, so if we have our event A as being draw a heart out of a possibility of drawing any card at all, then the probability of event A is equal to the number of ways that we can draw a heart divided by the number of ways that we could draw a card, period. And that boils down to, well, there's 13 hearts in a deck, so we could draw a heart 13 ways out of a total of 52 cards, which simplifies to 1 out of 4, or 0.25, or 25%. And our closing statement, therefore, there is a, let's go with decimals, a 0.25 probability of drawing a heart. Or if you're like me, there I drew a heart. Second one. Now we've done examples like this when we did counting, but we're going to revisit them a little bit. So 2 brothers enter a race with 5 friends. So one thing that we need to note from that is that there are 7 racers altogether. Okay, 2 brothers and 5 friends. The racers draw lanes to determine their starting positions. Okay, so from a picture standpoint, there are 1, 2, 3, 5, 6, 7 lanes. Okay, there are 7 lanes, and each of the racers are drawing what lane they're going to race in. So what's the probability that the 2 brothers are in lanes 1 and 2 in some order? Okay, so we'll call this lane 1 and this one lane 2. Now what the question asks is, what's the probability that the 2 brothers are in lanes 1 and 2? So for now, let's just put the older brother here, and the younger brother here. Okay? Now, in this case, we know that we could have or the younger brother in lane 1 and the older brother up top. So this leads to 2 factorial ways that the brothers are in lanes 1 and 2. Okay? Now, the other thing that we have to look at are the remaining 5 racers. Okay? So this way, the other 5 racers can draw 5 factorial arrangements. Okay? So if we look at the event A as being the brothers in lane 1 and lane 2, then the probability of the brothers being in lane 1 and lane 2 is equal to the number of ways that the brothers will be in lane 1 and lane 2 divided by the number of ways that the 7 racers can order themselves at all in general in any arrangement. So the number of ways that the brothers can be in lanes 1 and 2 is 2 factorial, right? So either older, younger in lanes 1 and 2, or younger, older in lanes 1 and 2. So 2 factorial. However, we have to account for the fact that the other 5 racers could be in any arrangement of 5. So that's how many different ways we can order the brothers in lanes 1 and 2. However, the total possible ways that the 7 people could be put in a lane is 7 factorial. And if you do that in your calculator, then I think we get 1 out of 42, or sorry, 2 out of 42, which is 1 out of 21. Okay? So that deals with our arrangement in terms of that, and if you do that in your calculator, you'll get a decimal or a percentage. Therefore, there is a 1 in 21 chance bros are in lane 1 or lane 2. Okay? So, as you can see, we're getting into our organized counting ways again, except now we're dealing with, rather than just answering the question, how many ways can there be in lanes 1 and 2? We're dealing with it in a probability sense. Next one. A focus group of 3 members is to be randomly selected from a medical team consisting of 5 doctors and 7 technicians. We've done this kind of question before as well. So there are 3 spots, but there are 12 people to choose from, right? 5 plus 7. What is the probability that the focus group will be comprised of only doctors? Okay, so let's look at A is the event of only doctors. Only doctors. So the probability of event A is equal to the number of ways that it can be only doctors divided by the number of ways that the committee could be selected at all in general. So if we're going to select 3 doctors, right, because it's only a committee of 3, if we're going to select 3 doctors and they all have to be doctors, well, we can only select them from 5 different doctors. So we're going to have 5 choose 3. However, there's 12 people altogether. Okay, so the ways that we can choose any 3 people would be 12 choose 3. And if you want to simplify that the long way, you can, or you can get out your calculator and do it. And if we do that, just to remind you of the buttons, we get 5 math probability 3, 5 choose 3, and that's an answer, divided by 12 choose 3, oops, that's permute, 12 choose 3, and it's 0.045 or 0.045 or 4.5%. There's a 4.5% chance of all doctors or all docs. Pretty slim chances. Now, what's the probability? This will be an interesting one. What's the probability that the focus group will not be comprised of only doctors? So, there's 2 ways. One of them is to say that the event A is not all docs. Now, this invites the question of, well, how many ways can there not be all doctors? What we need to do is figure out the probability that there is, well, rather than saying, one doctor or no doctors, we could have the probability of, out of 7 technicians, we could have the probability of there being all technicians instead. Okay, so we could look at no doctors. All techs, okay, and that would equal, well, there's 7 technicians, and if they're all techs, then we're choosing 3 of them, divided by 12, choose 3. And what does that simplify to? Well, 7 choose 3 is 35, divided by 12 choose 3, 12 choose 3, and that's 220. Now I'm willing to bet that that simplifies to, let's do 220 divided by 5, and that's 44, so that's 7 over 44. Okay, or roughly maybe a 1 in 6 chance. Now that's the probability of all technicians. Probability of 2 techs is 7 choose 2. However, the third spot has to be filled by 1 doctor. Divided by 12 choose 3. And that gives us, well, what's 7 choose 2 times 5. 21 times 5, 105. Out of 220. I'm willing to bet that's divisible by 5, and it's 21 out of 44. And lastly, the probability of 1 technician. And that is 7 choose 1 technician. However, we have to account for the fact that the other 2 spots are going to be filled by doctors. So 7 choose 1 is 7, but 5 choose 2 is 10. So 70 over 440. Whoops, not 440. 220. Or 70 divided by 5. So 14 over 44. Therefore, the probability of event A, which is not all doctors, right? We chose the event A as being not all doctors. That's going to be all of these things added up. So, what do we have? 14 out of 44 plus 21 out of 44 plus 7 out of 44. And that gives us, well, 14 plus 21 plus another 21 is 42 out of 44, which simplifies to 21 out of 22, a really high chance. So there's a chance of 21 out of 22, not all doctors. Okay, that's one way. The other way is to redefine the event A, or not necessarily redefine the event A. Using the event A, let's define A prime. which is if A is not all doctors, then A prime is going to be all doctors. So we know that the probability of A is equal to 100% probability minus the probability of A prime. This is the complement idea. And so 1 minus, now we already decided that the probability of having all doctors, this is the nice thing about doing this question first. The probability of having all doctors was, well, 5 choose 3 divided by 12 choose 3, which is 1 minus 12 choose 3, which is 220. Oops. I want 5 choose 3, which was 10 over 220, which simplifies to 1 minus 1 over 22, which lo and behold is 21 out of 22, which is what our answer was way down here. So that's the fast way of doing that one. It's a lot easier to use the indirect method. So I'll leave this to you guys for a moment, and we'll play the other video. Maybe I'll call it the birthday question or something. But feel free to give this one a try. See what you can come up with in about 5-10 minutes or so. Goodbye.